In late 2024, behind locked doors in a subterranean lab in Japan, Musk witnessed something so disruptive it shattered everything he built Tesla to prove. Not a battery, not a breakthrough in lithium, but something far more dangerous to Silicon Valley's dream. A new combustion engine, one that runs on hydrogen, crushes emissions, and doesn't need a single charging station. Why did Toyota keep this buried? What does it mean for American workers, Wall Street, and your future car? Because if Elon Musk, the prophet of the electric age, just flinched, then maybe the EV revolution isn't the future. Maybe it's already over. Toyota's hydrogen engine breakthrough. Toyota's new engine doesn't use batteries, it doesn't plug in, and it doesn't require a sprawling global network of chargers or rare earth mineral mines halfway across the world. Instead, it burns hydrogen, not by converting it into electricity like traditional fuel cell vehicles do, but through direct combustion, just like a gasoline engine. This engine is a hybrid in name only. It was designed to shatter the boundaries between combustion and electrification. Developed in deep partnership with Subaru and Mazda, powertrain is built to integrate seamlessly with electric motors, but it retains the visceral, mechanical force of piston-driven combustion. That means it can provide instant torque, long-range capability, and rapid refueling, all without emitting carbon dioxide. The only byproduct? Water vapor. More importantly, Toyota's engine isn't just designed for hydrogen. It can run on multiple fuel types, including synthetic fuels, biodiesel, and traditional gasoline, depending on regional infrastructure and supply availability. That makes it flexible in a way that no electric vehicle can currently match. There are no cobalt-laced batteries, no dependence on lithium, no need for a coal-powered grid to keep cars moving. By reverting to combustion while using carbon-neutral fuels, Toyota found a way to sidestep almost every challenge facing the electric vehicle sector, while simultaneously preserving the mechanical advantages of gas-powered engines. And the design changes are just as disruptive. Engineers shortened the piston stroke, making the engine 10 to 20% smaller than previous combustion blocks. This allows for lower hoods, better aerodynamics, and superior fuel efficiency. And to ensure no loss in torque, Toyota integrated electric motors for low-end response. The result is something that performs like a sports car, but emits like a wind turbine. The engine's compact footprint also means it can be deployed across Toyota's entire lineup, from tiny urban hatchbacks to heavy-duty pickup trucks. It's scalable, adaptable, and more importantly, nearly ready for market. Which makes you question, what's going to happen to Tesla then? It's a lot to unpack, so make sure you're subscribed before we dive in. Thanks. Why Tesla's battery empire is crumbling. Electric vehicle batteries were supposed to save the planet until they became a global problem. The dream of battery-powered vehicles was always rooted in a vision of clean energy, zero emissions, silent streets, an end to oil wars and smog-choked cities. But that dream came at a cost, one most consumers never saw. To build just one lithium-ion battery, automakers must mine thousands of pounds of earth. Lithium, cobalt, and nickel, three essential elements, are pulled from deep within the planet, often under horrifying conditions. In the Democratic Republic of Congo, children are frequently found in cobalt mines, working under slave-like conditions. In South America's so-called lithium triangle, vast amounts of water are diverted from indigenous communities to feed extraction wells in the desert. And in regions like Indonesia and the Philippines, nickel mining has devastated local ecosystems, leaving toxic sludge in its wake. And even after these minerals are harvested and refined, the process of assembling a single battery pack still releases staggering levels of greenhouse gases. Some studies estimate up to 4 tons of carbon dioxide are emitted just to manufacture the battery, meaning it can take years of driving to break even on carbon emissions. Then there's the end-of-life issue. Only 5% of lithium-ion batteries are recycled. The rest, dumped, leaking, polluting. There is no efficient, profitable way to recover most of the materials inside them. Yet, Toyota's engine bypasses all of this. It doesn't require strip mining, global mineral shipping, or rare earth refining. It can be built in regional plants, powered by local hydrogen production, and repaired using familiar, well-known tools and systems. In other words, it's sustainable, not just in theory, but in practice. That wasn't just an engineering win. It was a moral knockout, the silent collapse of Tesla's monopoly. Musk's silence said it all. Tesla just got outflanked on its home turf. For more than a decade, Tesla built its identity on a single, bold bet. The future is battery-powered, and nothing else matters. Every factory, every vehicle platform, every research dollar, they all revolved around one idea: electrify everything. There was no fallback plan, no contingency. Tesla didn't develop hybrid systems. It didn't explore combustion flexibility. It didn't build hydrogen infrastructure. But Toyota did. Tesla's so-called gigafactories, those sprawling battery plants in Nevada, Shanghai, and Berlin, are optimized entirely around lithium-based supply chains. That means any pivot away from battery-first production requires a total reinvention of the company's manufacturing model. And Wall Street noticed. After Musk's cryptic comment about Toyota's engine, Tesla's stock began fluctuating. Institutional investors started quietly asking questions. Why doesn't Tesla have a hydrogen roadmap? What if synthetic fuels overtake battery adoption in developing countries? Why is Toyota filing new powertrain patents while Tesla sticks to outdated architecture? For the first time since Tesla's meteoric rise, cracks began appearing in the narrative. It wasn't just about speed anymore, or style, or autonomy. It was about survival. Toyota didn't challenge Tesla at the high end of the market. It didn't roll out a flashy sports car. It built something deeper, an engine architecture that could change the entire energy equation behind personal mobility. And then, Toyota filed a patent Musk didn't see coming. The Ghost strategy, Toyota's long game. Their engineers weren't just tinkering in a lab. They were embedded in racing circuits, testing combustion engines under the most punishing conditions imaginable. They were working with chemical engineers, hydrogen specialists, and aerodynamicists who reimagined what a next-generation engine could be. All of this was part of a strategy designed not to win the next quarter, but to win the next 2 decades. While governments set ambitious targets for battery electric vehicle adoption, Toyota focused on infrastructure readiness. They knew that most regions lacked the grid capacity to support a full shift. They saw that charging stations remained limited, especially in rural and developing markets. Their goal wasn't to follow the hype. It was to wait for the moment when the world realized electric vehicles weren't a silver bullet. They weren't behind. They were patient. And now it's too late to catch them. The engineering masterstroke, shrinking the engine. This tiny engine might be the biggest threat Tesla has ever faced. To the untrained eye, it may look like just another power unit, but under the casing lies one of the most significant engineering advancements in modern automotive history. The breakthrough came not from adding complexity, but from stripping it down. Toyota's engineers shortened the piston stroke, a deceptively simple decision with massive consequences. This adjustment allowed them to shrink the entire engine block, making it between 10 and 20% smaller and lighter than current models. That size reduction created a cascade of benefits. With a smaller block, vehicles could be designed with lower hood profiles, improving both aesthetics and aerodynamic performance. The result? Better fuel economy and smoother high-speed handling. Smaller also meant more flexibility. These compact engines could fit into a broader range of vehicles, from subcompacts to full-size SUVs. And thanks to hybridization, the reduced torque from the shorter stroke was offset by the instant response of integrated electric motors. This wasn't just an internal combustion engine revival, it was a reinvention. What made this even more lethal to Tesla's battery dominance was that these engines could function in multiple configurations: fully combustion, mild hybrid, full hybrid, hydrogen capable, synthetic fuel compatible. This wasn't an engine for a single generation. It was a platform for the next half-century. Tesla's battery-only architecture suddenly looked rigid by comparison. Toyota had created not just an engine, but a modular powertrain system. And unlike battery packs, which degrade over time and require rare minerals, this new engine could be serviced, adapted, and refueled using an evolving ecosystem of cleaner fuels. The future didn't get quieter. Inside the Toyota Subaru Mazda pact, it wasn't just Toyota. This was an ambush, and 3 automakers were in on it. In an industry where cooperation usually means temporary alliances or badge-engineered partnerships, Toyota's 2024 announcement of a joint internal combustion engine development pact with Subaru and Mazda was seismic. While Tesla and other battery-focused companies were doubling down on electric-only strategies, this Japanese coalition was charting a different path. Together, they launched a coordinated research and development initiative centered on hydrogen combustion, synthetic fuels, and hybrid internal combustion engine systems. Each company brought unique assets to the table. Mazda contributed its deep experience with rotary engines and combustion efficiency. Subaru, long known for rugged all-wheel drive systems, supplied performance data and expertise from its motorsports division. And Toyota provided the backbone, manufacturing capability, hybrid know-how, and hydrogen infrastructure investment. What made this pact so potent was its structure. Not traditional corporate merger, but a framework of friendly competition. Each Each automaker would develop and test its own variations, but all discoveries would be shared. This eliminated redundancy while accelerating progress. Their engineers cross-trained. Their test tracks were shared. Their prototypes were co-developed. The goal was not simply to build a better engine. It was to outmaneuver an entire industry. In a world where Western automakers had siloed themselves into electric-only echo chambers, Japan had mobilized its finest minds across 3 giants to develop a technology portfolio that could survive blackouts, bypass rare earth dependencies, and deliver instant torque without range anxiety. They weren't just preparing to compete, they were preparing to dominate. The patents that frightened Wall Street. Toyota filed a new series of patents. Musk's engineers went silent. The documents revealed something few in Silicon Valley expected. Not just an engine, not just a combustion system, but a platform. Toyota had locked in the intellectual property for a series of modular hybrid hydrogen combustion systems designed to scale across nearly every class of vehicle, from subcompact city cars to heavy-duty trucks and performance machines. The new designs eliminated rare earth material dependencies. They featured combustion chambers optimized for hydrogen, ethanol, and synthetic fuels. Even more disruptive, the systems used electric motors only where necessary, reducing the overall reliance on battery packs. Wall Street analysts, previously bullish on battery electric vehicle dominance, began re-evaluating. For the first time, financial models included scenarios where Tesla's market share would not only stagnate but decline.